So this is how industry operates. So see, like in my conversation, you should have got the basic idea that there is secure environment and there is an environment where some amount of breaching is allowed. So security is
secure.
the key. Yeah, security is the key. Nowadays, many banks are moving towards Haskell because Haskell is known to be more secure than Java. So they are moving. They're taking small steps. Some of the banks have taken big steps to move towards Haskell.
Sir,
So
let's say if we want to begin towards the game, the competition, okay,
mm,
where should we start?
first
Means if I want to write,
check out
yeah,
the game.
yeah,
First, understand what the game is. Play some games. Okay, play a few Othello games. There are sites where you can play against a computer. Understand the moves. First, you should be familiar with the game. And then think about a representation for the board. How do you represent a state? What is a state in an Othello game? We have two players and there's a state. And when we make a move, the state transitions. So from state A, I make a move, I go to state B. So I made a move, now the state is B. Now B is handed over to the next player. And he makes a move, it goes to state C. C is handed over to the first player. And then it goes back and forth between these two players. So think about the state representation. What is a state? First of all, what do you need to capture about the Othello board in order for a computer to play the game? So you have to define first the state representation. It must be complete, but in your first attempt it won't be complete, but you will do it step by step, and you will populate all the fields, and then you'll say, okay, now my state is completely defined. I have all the information for me. Now you have to define a transition function, a move gen, that takes you from one state to the other. Now, of all the states that the move gen returns, now you have to determine which move is the best move. That is where your heuristics comes. AlphaGo, AlphaZero, AlphaGo does it in a machine learning manner. It's fantastic. I mean, you should read the paper, whether you understand it fully or not. At least go through the paper. It's freely available.
So how is reinforcement learning is different from AI?
Okay. See, AI, there are two components. There's a classical AI and there is a neural side of it, the machine learning side of it. See, classical AI deals, it's basically what you learn in this course. It's search methods, mostly deterministic and heuristic methods, and some stochastic methods. Okay, which has traditionally been used in the industry before this deep neural network became popular. Okay, neural networks existed for quite some time. It coexisted with other methods. So these methods, in fact, so the point is the chess engines were using alpha beta and SSS star and a variation of alpha beta mostly for a very long time. And Gary Kasparov was beat. The alpha beta is the one that beat Gary Kasparov, not neural network. Okay, but now neural network can beat alpha beta. It will beat alpha beta left, right, top, down, any time of the day, anywhere, any game, because this deep neural net has they have done such a good architecture that it can just take over alpha beta. It can beat alpha beta on any game. Okay, so that is the state of the development. That's the current state. But then alpha beta gives you the fundamental. It defines how to uh, write computer games, and it gives you the theory behind it, how to analyze games, what is a game mathematically speaking, and what do I represent, what is a strategy, and what are moves. So all those fundamentals are defined when you do this course. You take the fundamentals from here, you add neural systems to it, then you get a fantastic system. Without this fundamental, if you try to do neural systems, mostly it will fail because of lack of knowledge. You will try to rediscover alpha beta, you will try to rediscover all these notations on your own, and that will take 5-10 years, or that may not happen at all. You may you may find something very small, such so simple that anybody who attends the first week of the game playing lecture will know automatically. So that kind of knowledge you will get here. See, this is one of the one of the foundational courses in AI. There are two branches in AI. So this is one branch of AI.
Okay, sir.
So
Okay.
in this course, we are learning like mm, the the more we think, the better we can design a program.
Yes. See, you're learning more mathematics and algorithms here. Okay.
So in this game thing, like the better player will develop a better program.
Yes. They will strategize better.
Yes,
They will know that, look, DFID works here very well. This problem requires DFID kind of an approach.
the
No,
person
this
with better moves will, of course, will win.
will benefit. See,
Yeah.
and you can see, okay, clearly I can see A star is a very good fit in this game, in this situation. See, a game is not just one algorithm. So there'll be layers and layers of algorithms you have to write. You have to make a lot of decisions. For making decisions, what algorithm you use is what counts. So for games, alpha beta is at a very low level, as at a basic level where you are making moves. Then after that, you have to make a lot of decisions. So there you will know what algorithms to use, what fits best. And then you will also know where to use the neural algorithms, the deep networks.
Yes.
So you should know all, and then you should pick the ones that will work for your problem.
Okay, sir.
There is, see, did you watch the GPT video where I forgot his name? He talks about temperature parameter.
No, sir.
Oh my God, you guys are missing. Once you
Where?
watch that,
So
week
where
one,
was it?
week one notes.
Week
So
one
I
practice assignment.
Week one practice
so I have
assignment.
Okay,
watched
okay, okay.
I have watched every video.
Oh, fantastic. Okay, I have a good guy who is very sincere. Okay, now in one part where he describes, he asked the AI to generate stories, title for
Yes, sir,
story.
yes, sir, yes, sir, yes. So this is OpenAI,
Open AI.
company of Elon Musk.
Yeah, it's GPT-3.
Yeah,
He
yeah,
talks about
GPT.
GPT-3,
Yes,
and
sir.
there he asked, he got access to GPT-3, and then he experimented with, he asked
Gen-
GPT-3 to generate some stories and some title for stories, and it
Content
generated
for
beautiful,
YouTube
yeah,
video. Yes, sir.
YouTube video and so on. That's a fantastic video. That's a very good application of machine learning. No classical AI can do that. Period. What you learn in this course will not do that.
Okay.
Just simply forget it. Okay.
Yes, sir.
But there's a big but. But he will talk about a temperature parameter. You give the right temperature parameter, you get sensible output. You give the wrong temperature parameter, it's all gibberish, pure waste. Okay, you watch that video. So you see
Yeah, sure.
the videos that we guys gave you for week one, there are
Sir,
really
I
good
also
ones there.
watched nearly all the videos.
Oh, fantastic. So you should, I would put it this way, midway through the course, watch it again. And end of the course, watch it again.
Okay, sir.
You will understand what we are talking about, why we gave you those videos. Did you guys see the Boston Dynamics,
Yes, sir. Robots, sir.
robots, yeah, the
Yes, sir.
dog, and there's a mule and so on and so forth.
Yes,
Okay,
sir.
now think about what kind of systems operate that robot. What kind of programs is it? Python? One is language, Python or what? That is different. Language we are not worried about here. What kind of algorithms? Is it A star?
Neural networks,
Is it? I mean, it is not through and through neural networks. Some part will be neural network. That would be what?
the vision, deep.
The vision side will be
Mm.
neural network, and there will be a planning side. So if there's an obstacle, and then the robot has to go around the obstacle, so what algorithm they use to go around, find that path around the obstacle, and they will use an algorithm to see whether should I jump over the obstacle, or should I walk over the obstacle, or should I climb over the obstacle. So there is some amount of planning that happens. Sir will cover planning also. See, this course is a mix of lot of key ideas, cutting edge ideas, at one point cutting edge ideas, but still they remain key ideas in many of the domains. See, the Mars rover that they launched, a person from that team is a friend of Professor Deepak, and he used to come every year and give a talk in IIT Madras. So I never missed those talks. I sat for every one of his talks. Amazing level of practical knowledge. So we really saw how the ideas from this course is used in those rovers. Those rovers are not neural net rovers. Those rovers were launched before DeepMind, came up with this general purpose way of solving things. So there you will see planning algorithms being used. You will see the search methods being used, and they have a severe limit. The amount of memory on those machines are less. The power, the energy available to those processors are significantly less. Here I have a PowerPoint plug point. Again, you just plug it, you get unlimited power. On Mars, who is supplying power? Solar power is the only power. Then they have a limited nuclear reactor that's supplying power. Beyond that, see, you have to optimize for power, then you have to do all your things. Then beyond operating the machine, then there are these scientific instruments that have to be operated. Then you have to communicate with Earth, send images, signals back and forth. So if you look at the project as a whole, I mean, and his name is Kannarajan, and in one of the talks he was discussing about the autonomous rovers and uh, autonomous submarine vehicles. So they were experimenting with autonomous submarine vehicles. They'll just drop a submarine vehicle into a bay. The problem they were solving is they were trying to find out where the marine life is more. What does the marine life like? If I want more fish, what should I do? So what are the conditions in the water? Salinity, temperature, season, depth of the water, the how much light is penetrating through the water. Okay, what is the noise levels? So they are measuring various parameters in the sea, and they just throw this autonomous vehicle. The vehicle will make its own path trip based on the current conditions in the sea. It will seek out life. Where life is, it will go there, and it will collect all the data and come back. So they will drop it after 48 hours. They'll go and pick it up. So how do you plan where to go? How do you drive that machine to go to a place? That was done before deep neural networks. Now some part of neural networks can be used there. Okay, but when neural networks go wrong, they go miserably wrong, completely wrong. Are you guys aware of one pixel attack?
No, sir. Where it is?
Hello?
No, sir.
So what?
No, you're doing machine learning course, right? Do you know what is one pixel attack?
No, sir.
No,
Go
sir.
Google. Go Google. So this one pixel attack and the temperature parameter that I described in one of the videos, the week one video.
It is a scenario where only one pixel can be modified.
Yeah. And then the machine learning completely, it messes up the output. So they will give a cat in image classification. They will change one pixel in that image, and it will say it is a duck or something else. Completely different class. It won't even say a dog or a lion or related thing. It won't even say something that's
So
closely
it's
related.
showing a bird as a frog.
Yeah, exactly. So the one pixel attack is what the neural systems suffer from. It's a major issue. So imagine somebody using a neural system to find out if a traveler is a terrorist or not. This is practical application. I've traveled around the world. I have several passports filled up. Okay, I lost count of how many trips I've made around the world. And one practical problem is, by knowing the travel pattern of a person, his age and so on and so forth, there are some 40-50 parameters you feed into the system, and the system is going to say likely this guy is bad, watch this guy. If you write a neural system, and if it suffers from one pixel attack, poor traveler who is really a good guy, he'll be identified as a bad guy. And apply a neural system to a medical scenario where now there is a system that is monitoring the heart or a kidney or something like that. And if that system is susceptible to one pixel attack, meaning you have to choose your network models, your training data sets, and so many other things properly so that you can avoid one pixel attacks. And theoretically, it is not possible to avoid, but within a closed environment, we can avoid it. Okay. So if such a system is monitoring a nuclear reactor or a flight, it's autonomous flight, it's all devastating. See, it is nice to see all of this chess being played, AlphaGo. If something goes wrong, nobody is hurt. It's fine. But there are places where we can never use these systems as a critical system. You have to have something on top of it that will receive the input from the neural system, and then the actual judgment will be done by some other system. Okay. So you have to learn both. There is no I if I learn this, I'm better off. No, you have to learn both. I mean, that should be clear from what I described now. So both are needed, both are good, both are definitely needed. Neural alone will not survive. But in neural area, they are making tremendous amount of progress. Unbelievable amount of progress. Did you guys watch that video on how GPT works?
Oh, yes, sir.
Where they generate one word at a time, so they have to give a few set of sentences before to start
Yes,
it,
sir.
and then it will
And
generate.
Yes, sir. Yes, sir.
it will generate the
Yeah,
whole story.
yeah. So I will ask you a question. If it is generating a story, the story is based on what the network saw during training, right?
Right.
Isn't it? Okay. And then it takes various combinations of what it saw, and then it stitches it into a story. But the system doesn't understand the meaning of the story it stitched.
No.
No. So it's a pure machine that has understood the
It's a
rules of
numbers game.
grammar. Yeah, it's huh?
Numbers game. For machine, the only objective is to minimize the loss function.
Exactly.
So it will try all the numbers.
Yeah, it's a number game. It has minimized some function. Okay, and they have set up the parameters in such a way that the output is meaningful to us. If you change the parameter a little bit, the output will be messy. So neural systems either do extremely well or they do poor. To build a system that really does well, it is possible within a given, I'll say, closed environment where your inputs and outputs are fixed. I'm not going to get anything beyond this. I've fixed it. So that kind of system, and still it is susceptible to one pixel attack, but you can still, to some extent, see, controlling a washing machine. I would like a neural net to do that because it's very efficient in controlling the washing cycle. Say microwave, cooking. Neural nets are very good. Camera, when you're operating a camera, you want to focus on a person's face. Those are all neural systems. There is no classical AI that can even come close to what a neural system can do. So there only neural system can be applied. So in fact, Sony camera way back, they had a neural system. So nowadays, in your phones and cameras, digital cameras, when you point at a scene, it'll identify the faces. It'll draw squares around the face, right?
Yes, sir.
And you guys are used to that feature. When we bought cameras, we didn't buy phones in those days. Phones did not have cameras, and they used to sell cameras saying that this feature is there. It'll automatically detect faces and it'll focus. Okay, so that was the time when they were developing those features, and we had cameras without those features, and with those features we could clearly see the difference between the picture. Okay, those are developed using neural systems. If something goes wrong in that picture, nobody is going to get hurt. And it's a very closed environment. It's very fixed. Bounds are very well defined, and nobody's going to get hurt. Their neural is good. So I think we are over by 30 minutes, right?
Right.
We ran over
Sir,
the
yesterday OpenAI released a new neural net called Whispers, which is a transcription software.
Okay.
Is that possible in classic AI?
See, the quality of output that neural systems give, I've not seen that in classical AI. Simply, it's not possible. Okay, it's not possible.
Okay.
Sir,
But
I have just
the kind of, see, with classical AI, you can explain things very well. Why this happened and how to back it out. What are the alternatives using search methods? So you can apply it to problems where your explanation is very much needed, where you need control over what the system is doing. Okay.
Okay.
So when it comes
So
to,
it's a white box versus black box issue.
yeah, exactly.
Okay.
sir.
Okay.
So just like the Mars rover, is the industry is going toward making a a drone that will be or fighter plane that can be run by their own.
See, defense has all kinds of projects. They don't discuss, and I'm not an expert in defense, but I would speculate, yeah, probably they're doing it. But if you look at, okay, Mars rover, like, so I'm a
Yes, sir.
student. I want to start a company. I want to join a company. I want to know what the future is. I've taken this BFC online course. I want to secure my future, get married, earn money, settle, buy house, buy car, and so on and so forth. I want my children to be successful. I'm talking from that perspective. Okay.
Okay, sir.
This is the golden age for AI. In classical AI, we have discovered a lot of things. We know its limits. We know its power. Okay. And in deep neural AI, we are making progress. We have made a lot of good progress. We are seeing the benefits of all of those things.
Okay, sir.
Now, what are the practical applications? Where can I apply? Where can I get a job? Can I succeed in life? That kind of question. Yes. If you look at agriculture, weather monitoring, sea monitoring, anywhere you want to put something and monitor, okay,
Mm.
AI systems are needed. You cannot have a person, see, when MH370 disappeared, right? MH370, you guys are aware of the flight that disappeared,
Yes, yes, sir.
the Malaysia flight.
Yes,
They
yes.
still could not find it. And
Yes, sir.
Australia deployed a autonomous vehicle to search the seafloor. Okay, so just take that task of, no, I'm going to search a seabed, which is, I don't know, millions of square kilometers, wide. It's a huge area, and I have few I, autonomous vehicles. No, is there an alternative to autonomous vehicles there? If you want to scan,
Mm,
I don't see an
mm,
alternative.
yes.
And this is a problem that is suitable for a robo. If you give the robo the basic features of, look, there is an obstacle, avoid it, and I'm looking for shapes like this. These are flight shapes. So I'm looking for objects of, that have a curvature and it's elongated and that's kind of out of place in its environment. These parameters you can describe. And the machine has to have enough power to dive deep, has to have enough power to scan the surface, process the image, identify, and based on what it has seen, it has to now navigate to a place where it has the highest probability of finding similar objects and so on and so forth. This is a very good problem for an autonomous vehicle. And there, both classical AI and the newer AI in combination is a good fit. If one pixel attack happens to to an autonomous vehicle, you will lose the vehicle. See, I have friends who are doing this drone, the for agriculture. They're spraying medicine, okay, spraying fertilizers for crops. You know what they complain often? Can you guess what they complain often?
Mm, no, sir.
They say, I start my drone. I have set the parameters. So this is the boundary. You have to fly within the boundary. For some reason, it goes out of the boundary and it goes in its own direction. It does not, and it is not, I'm not able to control using my remote from ground.
Why, sir?
Yeah, that is a fundamental question. Why? And I know those drones are not using very deep AI. There are some basic control systems there. Maybe there is some AI. I have not seen them. I do not know their circuit boards, or processors, or whatnot, the storage and software. I'm not aware of any of those things. But as students, can you think of why it is going? It is just erratically flying in one direction. So this guy pays 1.5 lakhs, 2 lakhs. Early days, it was 3 lakhs, 4 lakhs per drone. He wants to recover his money by spraying medicine and spraying fertilizers. He goes to a place, he turns on, and then this drone simply disappears. He puts a marker. The drone says, "This is a marker. You are supposed to fly within this boundary."
So maybe the marker set by the person is likely to find somewhere else by the drone.
Yeah, we don't know. It's a debugging exercise, right? Something has gone wrong. You're debugging that situation. But now the question is, will you use a classical AI system there, or will you use a neural AI which has one pixel vulnerability, right? One pixel attack vulnerability.
Classical
Neural.
AI, because that is
classical
easy to
is a
debug.
better option, I guess.
Yeah, so that can give a feedback, and I will know. I can come back to my lab. Though I would have lost one drone, I can take the other drone. I can see where all it could have gone wrong. I can go do a code review. I can do some testing. I mean, we can do testing similarly for neural also. No, I'm not saying it's not possible. It's possible there, but things can go unexpectedly wrong with neural. So the conversation is, I'm not saying neural is bad. I'm saying you have to be cautious when you design such systems. You have to consciously design it so to eliminate such attacks.
So
If you
can
do that, then neural is good.
one pixel attack can't be
Eliminate it,
Mitigated.
you're
solve?
saying.
Yeah, solve.
Yeah, it can be, but when you put solutions for one pixel attack, the quality of the output suffers. The neural performance and the classical AI performance will be comparable. Still, neural will do better than classic.
So
It will still do better in
efficiency
those
is
areas.
better in which kind of algorithms, in neural or in classical? Yeah.
In terms of computational efficiency, neural is very, way, way, way good because it's only a bunch of matrix multiplications and nothing more. See what neural systems do. If you break down your neural network, if you open it and see inside computationally, they're all matrix multiplication.
Right.
You have a bunch of numbers coming in, you do matrix multiplication, you get a bunch of numbers out, and
Yes.
finally, after several matrix operations, you get one number, and based on that number, you bet your life on that.
Sir, you told that there will be two programming assignments.
Mm.
So the document says that 100 marks are allotted for the course, and the two
Okay.
programming assign and the two programming assignments constitute of 10 marks, and they are given as a bonus. On
Okay.
top of that, you told that the game will also be graded.
No, I
So,
told subject to the condition that they have already announced it. If they have not announced it, then there is no game.
oh no, see that I want to play the game, so I will assume that the game is already announced, and I
Okay.
hope, yeah, I
See, we
hope that,
also want to
I
do
was
it, but
also
we are,
hoping to play the game.
yeah.
yeah,
See, we have our own constraints in terms of resources and hardware, software, people, time. Okay. So we are working within constraints. We are not an industry where we are making profits and things like that. It's an academy. In academia, we are always short of funds. We are short of people. So in
sir,
industry,
you can
yeah,
utilize
yeah.
us if you want. Like I am
Uh,
ready to help.
okay. As long as you're a student in this run, I can get you involved. But once you clear this course, then you can get involved. You
Okay,
see, there's a conflict of interest, right?
yeah, yeah,
See, you write a framework, you will know everything about it. Then the bot that you write will be more efficient. It's unfair for others. Completely unfair.
Yes, sir. Yes.
okay,
Okay, it's biased.
okay.
But on the other hand, once you clear it, you know how the system works. So by then we already will have a system. Right? So once the tournament is done, then we will already have a system. We don't need help. So
Yeah,
it's kind of fishy. I don't know what the announcement is. I've not seen it. So you have seen it. See, we are trying to make this very interesting for students. Students should feel, okay, I've learned a great deal of material from this. It's all practical. It's used in the industry. I know if I want to develop this, I know what algorithms to use. We want the people to get to that level of proficiency. Outright going out, they may not write the best, the top of the class, top of the line programs, but at least they should have the confidence, I can write it. They should know how much effort it takes to write and things like that. So that is the general idea here. So, in fact, this is one of the best courses, and Professor Deepak is one of the best teachers, and in IIT he is very popular. And his delivery, I mean, you should sit for his live lectures. Oh my God, oh, it's massive. You can feel the amount of energy that radiates from that man. Okay, and it is very infectious. It just infects all the students, and the kind of things that he discusses. Videos do not do any justice. See, in videos, I see some typos. People get confused because of typos, and he does mental arithmetic on the fly. And when he, without using spreadsheets, see, I use spreadsheets. I verify my answers using spreadsheets. And he is from the previous generation, and they are used to making calculations in their head. And when he does so, some mistakes happen, and because of that, in the slide you will find, something is not, some number is not correct. Concepts are all correct. Instead of saying 10,024, he'll say 10,124, and it messes up when students go and verify. It gets messed up. They don't understand, and they get frustrated. So, but that is not the actual thing. You should understand what the concept is, and then work it out on your own. And few gaps here and there. That is where I come in. I try to put practice assignments to fill in the gaps there. That is my job to fill in. Okay, so I'll try to do my best. And so when you listen to lectures, listen to the big concept, listen to the approach he's taking to solve it, and just mimic what he's doing once. Take the exact problem he is solving. Now you solve it on your own without watching the video. You can crack the exam. You will understand the concepts clearly. After doing that, you go implement it in the language of your choice. Then you are ready for the industry. When you sit for an interview, you can say, I've done this. I've experimented with this. I understand the limits and bounds and complexity, and so on and so forth. I know what fits where, given my whatever coursework I have done. Of course, I don't know everything, but within the limits of the coursework I've done, I know these things. You will be very confident. Okay. So, see, I'll tell you, this classical AI has been developed, used in many places. It is also being used. It will be used in the future, but now it will be used in combination with neural.
Okay.
Okay, there are problems that neural can solve which classical AI cannot solve, and there are problems that classical AI can solve that neural cannot solve. Okay, so that way both are needed. But right now in the industry, what is popular? Looking at the industry, what Google is doing, what Musk is doing, the neural AI is the top famous. It's popular in the news, and it's popular with people, and they're also doing good work. So, okay.
Also, sir, last question. Like I saw some previous NPTEL lectures, and
Okay.
during that, sir used Blackboard.
Yeah,
Why was
exactly.
that removed? Like I think Blackboard is more spontaneous in explanations.
Yeah, exactly. It is. I think we like watching that because you really feel the man talk there. Okay, you'll see the experience just come out, and when you ask questions, the way he explains it, it's beautiful. Uh, we with NPTEL we had this problem. His handwriting is cursive handwriting.
No, yes, his handwriting is typical teacher's handwriting.
Yeah, it's cursive, and people don't get it. Okay, and we saw that people were dropping off just because they did not, understand some basic concept. Their mindset is, yeah, I don't even understand this. How can I continue? I was not able to complete this assignment. How can I continue? That is where the transcripts played a big role, and we did transcription, and that was still not enough. People said, we can you give us slides which we can review, and then we changed the format. And most of the NPTEL courses at that time, see, NPTEL started, they didn't know what format is good. It was early stages, so they simply recorded the classroom session and then they gave it to colleges, and it was given in hard drives. So periodic updates used to be sent through hard drives to all Indian colleges, and in fact they were running it and they were playing it locally. Only now it is through YouTube. Okay. Uh, so at that time, and then it became popular, and then people started finding issues with that kind of format. Slowly moved to this, and now it is all PowerPoint. And yeah, it helps also, but you miss seeing the person in real time. Okay.
Okay.
Anyway, so that is the thing. And see, best of lucks to you all. So I would say you mimic what he is doing. Do hand calculations. Okay. Use the
sir.
forum heavily. Use the forum heavily. I respond very well to forum. It may not be on time, but give it 1 or 2 days. You know, I try to respond immediately, but sometimes things take time. Too many things to do and things take time. But I respond to all technical questions. All my NPTEL forums, all 4 runs, I handle 2 courses a year, 1 course a semester. And so far I've done 8 runs. All my forum response, all my forum posts, technical posts, I answer in full with full detail. Okay, even if one student benefits, I'm happy about it. So forum is a very good way of exchanging information.
Okay. Sir, in the next session, if possible, can you show us a basic implementation of an AI game
Uh,
that you
yeah.
might have implemented before, like for any purposes?
Yeah, given the amount of time I have right now, see right now the quiz papers have to be set. 25th is the deadline. I have to give them 2 sets of papers. Week 4 assignment is due by Friday, and today is Thursday, and I'm halfway through it. Practice assignments and graded assignment. I'm also handling the NPTEL course for this one. That week 9 is pending. I have to give it by this week. I think week 9 I gave. Week 10 is pending now. I have to give week 10. So I have to finish week 10. I have to finish week 4 for online degree, week 10 for NPTEL. Then I have to prepare, not me, not I means not I alone. Uh, I work with professor, so 2 of us. And when I say I, you have to understand that it's 2 of us we are doing. Okay, not just me alone. And the 2 quiz papers have to go. And
Sir,
these are
can we
all
have?
hard deadlines. These are all very hard deadlines. I cannot move these deadlines.
Okay.
Okay.
So,
So,
if
but
possible,
okay, don't see, reduce your anxiety level. We are trying to make it as educative as possible,
Yes,
as
yes.
not trivial as possible, not trivial, but reduce the unnecessary difficulties in gameplay.
okay,
Okay, there is a
okay, okay.
lot of things that we will take care from the framework end. Board representation will take care. Move representation will take all the representation things where if we allow the students to do it, each student will do in their own way. They will do in their own way. And some the people have a natural tendency to write good programs. They're naturally good programmers. They will do very well. But some people are good in thinking and mathematics. They can write good papers, come up with good idea. But when it comes to implementation, they'll just fail miserably. But they're good thinkers. We have seen various types of students, and I've seen various types of people in the industry as well. See, one of the key papers and compilers, SSA, right? What is the full form for SSA? Single static assignment. Yeah, that basically discovers what aliases and pointers or something like that. I vaguely, I'm trying to recall. The fund until before the best work was written, the best algorithm was written. Until before, people didn't have a clue how to solve it, and it was just very vague. But the person who did that is autistic, I believe. His social skills are very poor. His writing skills are very poor. I'm saying poor means poor. Okay, when you if he tries to get into IIT, he'll be rejected. If he tries to get into some industry, he'll be rejected. He can't do well. But people, he was working in, I think, in a university, and in a PhD program, one of the postdocs understood the limitations that the person had, also understood the person's key strength. Okay, and that person was visual in nature. He was able to express everything using diagrams, geometry, cutting planes. So he basically explained the whole idea of SSA, single static assignment, using cutting planes and geometry, which a postdoc sat and translated, understood, and that it is actually a good idea, it works, and then took him and she went to the guide and said, guide, look at this guy. He has a very good idea. His ideas work. Please listen to him. But he is only able to talk using geometry and figures. But we want an algorithm out of it. So this is, they listened to him. They said, oh, boss, you cracked the problem. This is the solution for it. They published it. So we see all kinds of people in academia, also in industry. So we don't want to have those differences impact their grades. People are really good, but in different ways they are good. So basically, we are going to nullify the effects of born programmers, little bit, not in a bad way, in a good way, and we're trying to help out, make it as uniform as possible for everybody. So don't worry much. When time comes, you will know, you will find out that yeah, it's not much. But the key thing you have to focus on is not in coding. Yeah, coding is there. You have to focus on what ideas you're going to use to handle the problem.
Logic, sir.
Logic, what algorithm, what concepts, what problems exist. So now if you play the game, think about the whole thing as a designer, as an analyst, not as a programmer who will sit and write lines of code. Programming is a very low level activity. Think about it mathematically, analyze it, strategize it, come with basic fundamental ideas how to attack the problem, and then you can implement it in any language you want. So play the game, understand how you will represent it, discuss it in the forum. Let every see, the best thing about the forum and the kind of thing that NPTEL is doing is that everybody gets benefited from everybody else's effort. That's a good thing, because when you put it out there, somebody else is going to point out a mistake or they'll develop it further. You will get a comment on it saying, if you do it this way, it's even better. So the author also gets benefited. The audience will also get benefited. So the community, the 54 people who have got enrolled to this course, all of them together will get benefited. So the competition is not between you guys. The competition is between the 54 versus the world outside. You understand? You're all in the same boat. Now, as a team, you have to win. So the competition is not between you guys. It is between you and the outside world. You have to take it that way. It's a positive thing to put things in the forum and share it. Okay.
Okay, sir.
So that's the way it is. But there is some part that you will keep it secret because finally it's grades. You don't want to reveal everything, right? There is also that component. So the general discussion we can have. Anyway, it was good. Okay, is there anything I had in my list? Well, let me check. Okay, I think I pretty much covered. I only had 2-3 items on my list. I was waiting for you guys to ask doubt. So, okay. Just focus, look at the notes, look at the algorithm trace published in the notes. And when you do your manual calculation of the problem that professor is solving, you do it manually and you compare it with the trace and see whether you are complying with the trace. If you are, then what you do, the answers that you give in the assignments and exams, the auto grader will grade it correctly. That's the main point I want to drive, in terms of assignments and exams. Okay. Thank you, guys.
Thank you, sir.
Thank you, sir.
Yeah, thank you all. Yeah, bye. See, anything and everything, you put it in the forum, let's prepare and then come for the session.
Okay,
Okay.
sir.
It makes it
thank you.
easy. See, if this endpoints, if you had posted, I would have downloaded that code on my machine here. And I'm on a different machine. Okay.
I would have, sir, but I started working on it today only because I was preparing for deep learning. We
Okay.
also have a hard week in that.
Okay. So do they have this endpoints in deep learning?
They do have a deep learning. They do not have NPs.
Okay. See, one thing you should, mm, it's a gentleman's code. You should not take an assignment from another course and get an answer from here. Or same thing, you take a question from here, get an answer from another course. It's a gentleman's code. There is no police enforcing it. So you have to enforce it. Rather than getting an answer, you should try, you should fail, and you should discover it. So that's much more powerful because it will make you a better thinker. At the end of it, you have to be a better thinker. Grades don't matter.
Yes.
Okay,
Okay.
sir.
Really, grades don't matter. It's only how much you got from the course, how much you are able to think, how much you are able to solve. That's what matters.
Okay,
Also,
sir.
sir, I'm trying to solve classical AI problems in classical AI domain only. I'm not trying to use deep learning because that would be first, I will not be able to develop concepts. Second, it
Okay.
would be straight cheating. Because in deep learning, we do not have to think about the rules and
The
things.
model,
You just put the data and you put the results and it will figure it out.
yeah, it's all data driven. If data contains all the patterns, then the system is going to learn. Once the system learns, what did you learn from the exercise?
Yeah, which is why I'm just trying to keep it in this domain only, classical
Yeah.
AI. In fact, like before this session, I did not know this is called as classical AI. I thought it is just something continuation of DSA. So this session has
E-
been
okay. See, the way you said it is really nice. One way it is true. What you said is true. Okay, one way. And that statement applies to much of what we do in CS, computer science, in computing. You take DBMS, you'll see it's just data structures and algorithms, right?
uh,
So data structures, DSA is so foundational, you will see that everywhere in all branches of computing science, including deep learning. Of course, apart from the new, if you go into it, you will see that we use matrices and we do matrix multiplication and then we maintain graphs, which are also data structures. So DSA is so foundational. It is like the air that we breathe. It is there everywhere. It is needed for survival. So everything will look like DSA. Where this course differs is it brings problems from many domains together into one course and it discusses domain independent algorithms for solving it. Search methods is fundamentally an algorithms thing. But what are the heuristic techniques and what works, what does not work, what is good? That is what this course introduces. So you go into operating systems course, don't you see DSA there?
yes,
You will see DSA there, right?
yes, yes.
You go into compilers,
Yeah. Okay, yeah. DSA is also like the DSA is a basic one because we have to keep
it's
about
such a
time.
basic, yeah, it's there everywhere. Only thing is in compilers you will learn how to write productions and rules, production rules, and you learn how to write a parser. If you write a parser, it constructs a parse tree, then it constructs an abstraction text tree. They're all data structures. You're operating in data structures. When you do a single static assignment, that's another algorithm, that's another data structure. When you do a data flow analysis, that's another data structure, that's another algorithm. So you will see DSA everywhere.
Right.
So DSA is basic, it is given. But what algorithms you use, if you look at handbook of machine learning, you will see a lot of DSA there. Okay. So yeah, it is true. What you said, it appears to be an extension of DSA, but so are other courses that are extensions of DSA in many ways. And also, you will learn how to apply the DSA to solve real life problems. Not only that, you will see algorithms that were specifically developed for addressing AI problems. So anything you write, everything you write will be a data structure and an algorithm. Because a program like SIR's KRR course in NPTEL, He makes a statement. It's by Robert Kowalski. He's a very popular. He's the creator of Prolog language. Prolog language itself, the very basic concept of Prolog, and that I can do computation using relations and using logic. Logic is computation. Computation is logic. So the discovery of that idea, that it was done by Robert Kowalski, and he very famously said, programs equal to, he gives you an equation, program equal to logic plus control. Control is where you do things, logic is where it splits into data structure and algorithms. So it's a very basic thing. Okay.
Okay, sir.
Okay, sir.
Thank you. Yeah, thank you.
Okay, thank you.
Yeah.
Thank you, sir. Sir, next meeting will be on.
How to find time. See, if you guys ask more doubts in the forum, then that will give me a focus. See, given the number of items I'm handling, unless you push, see, this kind of started and then we went somewhere else. I wanted it to be a nice doubt clearing session, intellectual questions, and
Okay.
then nice answers given. If I'm not able to give, at least I'll address it in the forum following after the session and so on and so forth. See, I want this to be, this one I did a motivational. I tried to address some of your questions, industry, where it is applied, and so it is needed at some point. We have to do it. It's better we do it now in the first session. It's fine. But from next session onwards, we'll keep this general motivational thing to a small part. We can still have motivational part. We need motivation from time to time. So we'll keep that to say 10, 15 minutes, and then rest of the things we'll discuss content.
Okay.
You can ask left, right, top, down, any question. I will not know answers for all the questions, but I can always get back. But I'll be able to answer most of the questions. Right?
I had two doubts, I thought more people will come, but very few joined. I had two doubts about NQueen and Oracle.
Then Queen
I
and?
think Oracle. You answered, sir.
No, I didn't. The voice is not clear.
NQueen and Oracle.
Oh, Oracle. Okay.
Yeah,
Okay,
Oracle.
Oracle.
So,
Okay.
so I think next week will be harder, and then subsequent weeks will get on harder. So we will get more questions.
Okay.
So we will ask you a lot of questions, sir. Don't worry on
Yeah,
that.
that is good. Yeah, that is good. So that is good. That is actually good. That is where you benefit and I also benefit. Okay.
Yes.
Okay. Thank you, guys.
Okay, thank you, sir.
Yeah.
Yeah. Thank you.